Hello, my name is Rajiv Bungirwar, Chief Executive Officer of Himraj Consulting. In the next 20 minutes, I will share my improved technique STPA Plus, helping you in achieving safety simply and quickly. But before that, let me share a little bit about myself. I'm an author, speaker, and a successful track record of designing functional safety upfront in high demand products in the automotive and aerospace industries. I'm a contributor to international standards and guidance such as UL 4600, evaluation of safety of autonomous vehicles and other products, and safety of autonomous systems working group in the Safety Critical Systems Club UK. I have been recognized as an industry leader by the American biographer Marquis Huzu. In 1995, I traveled over 6,200 miles, touching the four corners of India in a month's time, and since then have been performing many adventurous road journeys worldwide. In the next 20 minutes, I will be covering the statistics of current day vehicle recalls in the automotive industry and discuss the solution of containing this concern by using STPA Plus. With the help of a real-life example showing the applicability and advantages of STPA Plus. I will then summarize by sharing the benefits of applying STPA Plus technique and where to find further information. Without further ado, let's look at the statistics of vehicle recalls troubling the current automotive industry. The slide shows the number of million vehicles affected because of defects in electronics and software for each year. As you can see, this number kept on rising until 2016 when it dropped for the first time. Unfortunately, it again continued to rise and kept increasing until 2019. So we need to find a way of containing these rising defects in electronics and software. Otherwise, it will defeat the advantages promised by the new technologies such as electromobility and autonomous vehicles. Let us look at the technology. We started off with the analog computers ENIAC and have been applying different safety analysis techniques such as failure mode effects analysis, fault tree analysis, event tree analysis, and bow tie. Come mid-70s, the era of digital computers began, and with Moore's law, the number of transistors doubling every square centimeter of silicon, we have an explosion of electronics, software, internet of things, cloud, autonomous vehicles, connected vehicles, and whatnot. And with this change, one important fact is now clear that if the components are reliable, it does not necessarily mean that the vehicle is safe. Over 1.3 million people are dying in road accidents every year, and 15 million vehicles were recalled in 2019 because of defects in electronics and software. In the same year, over 3 vehicles were recalled for every new one manufactured. We have to find a way to maximize the reduction and identification of hazards and their causes before the first vehicle drive. So let us review the current situation with electronic product development across industries. The currently used analysis techniques are not being proven to be effective for curbing the defects in electronics and software. development time has been increasing and the development costs have been skyrocketing because of increased components, software, interactions, complexities, and new technologies. What we need is an innovative solution to harness the advantages promised by these new technologies. As Abraham Lincoln said, the best way to predict the future is to create it. Let's use STPA Plus to create safer and reliable vehicles and save human lives. It also helps in avoiding penalties and fines and maximizing your profits. It helps create great products on time and on budget. And it establishes or reinforces your brand reputation. It provides an excellent return on investment in the time and effort invested in applying this analysis technique during the product design and development life cycle. If you think safety is expensive, try an accident is a very well-known saying. I will now share with you my STPA Plus methodology. When you design a system from scratch, by default, it could be both unreliable and unsafe. Let us now apply the failure mode effects analysis technique, and that could help make the system reliable, but it could be unsafe. Since 2005, STPA has been applied, and that could help the system be designed to be safe, but it could be unreliable. So the need of the hour is to apply a technique which helps design a safe and reliable system, which is the promise of STPA Plus. Safety versus reliability. It is important to know the difference. A safe system does not necessarily mean it is reliable, and a reliable system does not necessarily mean it is safe. They are two independent properties and need to be satisfied collectively. Let us look at the benefits of STPA Plus over the original STPA. STPA Plus helps with the integration of design and development process with the analysis technique. It helps in ongoing bidirectional traceability, early identification and resolution of defects. It helps in the objective completion assessment of the analysis for a given scope. It also helps in the removal of conflicts and ambiguity when complying with the ISO 26262 standard because of the relationship it creates in the different work products and aligns them. Safe and reliable components, systems, and vehicles. That's what you get from using STPA Plus. It is based on the foundation STPA developed by Nancy Levison and John P. Thomas of MIT, USA. First deployed in the industry in 2005. It is my modified version, better aligned with the terminology of ISO 26262 and helps in achieving compliance effectively and efficiently. In summary, STPA Plus enables effective ISO 26262 compliance with less time and less money. Let us look at the scope of STPA Plus analysis. Of course, safety is the number one aspect, but it does much more than that. It also looks at the voice of legislation to ensure that the vehicle is roadworthy during its journey. It also listens to the voice of customer and avoids mission loss and customer dissatisfaction. It also looks at the voice of business by maximizing profits and protecting your brand reputation and ensuring compliance with the trust mark requirements. And last but not the least, It also analyzes security threats. Let us now look at the 4 steps of the STPA plus analysis based on the original STPA. The first step is to define the purpose of the analysis, identify the system boundary, system environment, vehicle level hazards. The second step is to identify the control structures aligned with the system hierarchy. In the third step, we identify the unsafe control actions which could result in the hazards leading to an accident, which leads us to the last step 4, to identify the loss scenarios where the accidents could happen. Let's take a look at a real-world STPA plus example.
At Volvo Trucks, we have always put safety above all else. A prime example of this is our LED lights with adaptive high beam that provide far better nighttime driving conditions. When the camera detects other vehicles, the adaptive high beam switches off the LED segments that would otherwise dazzle drivers of vehicles ahead and approaching. The high beam still lights up the unaffected parts of the road. No matter when.
So you have seen how adaptive driving beam can help improve visibility at night. Let us now apply STPA plus to identify the hazards and the unsafe control actions. What are the hazards? So if you look at the oncoming vehicles, the drivers of the oncoming vehicles could be blinded with the high beam. Similarly, the driver of the vehicle ahead could be blinded. And lastly, the driver of the ego vehicle in consideration will have poor visibility of the road ahead if the headlamps are off. So let's now identify the control structure of headlamps in step 2. At the top level, the driver is in control of the vehicle, which is driving on the road in the midst of an environment. We then have intermediate electronic control units, such as the instrument cluster and body control module, as well as the headlamp control unit controlling the sectors of the LEDs in the high beam and low beam of the headlamps. These are the control blocks of the system. And as you can see, you now have the blue arrows from top to down, which are the control actions from the controller sent to the controlled elements. And the pink arrows are the feedback sent back by the control elements to the controllers, so that the controller can then understand the actual status of the control element and compare it with the element model of the control element, which aligns with the different work products such as item definition, subsystem specification of ISO 26262. Let us now move forward to step 3 and identify the unsafe control actions. The unsafe control actions are aligned with the hazards that we have identified in step 1. So the first relates to the oncoming vehicle. The high beam shape does not change in the presence of an oncoming vehicle, which could blind the driver of the oncoming vehicle. Similarly, when there is a vehicle ahead near, the headlamp beam shape needs to change so that the drivers of the vehicles ahead are not blinded. And lastly, the ego vehicle driver will have a poor road visibility if the headlamp is not switched on. Let us summarize how the STPA Plus can be applied and its advantages. So the first and foremost step is it helps you in maximizing the identification of hazards. It provides early feedback through an independent perspective by interweaving the creation of the work products and using STPA Plus analysis that is aligned with the system architecture and the system hierarchy. It also helps you to refine the input work products which are prerequisite. For example, when you apply STPA plus to perform hazard analysis, it can help in refining the item definition to resolve conflicting requirements or incompatible interfaces. It also helps you to comply with safety of the intended functionality and cybersecurity by performing the same analysis on the same system. So, in effect, the analysis could be performed in days and weeks as compared to weeks, months, or over a year using traditional analysis techniques. So, success is there for those who dare to use new techniques, adapt it, and leverage it to their advantage. Where to find more information? If you are interested in watching a detailed step-by-step application of STPA Plus technique, please watch my Learning Labs video in the SAE WCX digital event. Himraj Consulting also have a digital booth with our partner where you can drop in, have a one-to-one interaction with me, ask any questions, or discuss how this STPA Plus could be applied in your projects. You can also book a one-to-one meeting with me using my calendar on the website at the link shown. Thank you for listening, and if you want to contact me, you can email me or contact us through our website or scan the QR code and connect with me on LinkedIn. I would like to thank Nancy Levison, John Thomas, and Stout for allowing me to reuse their figures and captions, Volvo Trucks for permitting me to share their video on adaptive high beams, and have also provided some references for those of you interested in more details. Thank you and look forward to see you in my next session.